Welcome to qnawire.
In this question, we have two charged non-conducting rods, okay, and then they carry 2.5 microcoulomb of charges, okay, just that one of them is positive, the other one is negative, okay. Then we want to find the magnitude and direction of the electric field at point P, and then the distance is 60 cm. Okay, this is 60 cm. This is also 60 cm. Okay. And after that, if we place a electron at P, if you release the electron at P, we want to find the magnitude and direction of net force. Okay, exert on it. Okay, so to do part A, okay, first we need to draw out the electric field due to each rod at point P. So due to the positive one, it will be pointing down. Due to the negative one, it will be pointing to the left. Okay, and since they are equidistant, okay, so we expect these two E plus and E minus to be of the same magnitude. And then since they are 90 degrees, and the resultant will be at a 45-degree angle, okay, below the horizontal. Okay, so yeah, and the magnitude will just be square root 2 of one of them. Okay, because you can calculate it using Pythagoras theorem. Okay, so after doing the analysis, we'll be using the electric field due to a charged rod, and this is equal to 1 over 4 pi epsilon naught q over x square root x squared plus a squared. Okay, so the a is 0.6 meters. Okay, and then the x is also 0.6 meters. Okay, the x refers to this distance. This is the x, and then this is our 2a. Okay, so which is why the a is 0.6 meters, x is 0.6 meters. Okay, and then our q is 2.5 times 10 to the negative 6 coulomb. So the E net, or the E at P, is square root 2 of E plus, okay, as we analyzed just now. Okay, so E plus and E minus are the same magnitude. Using Pythagoras theorem, okay, we have a right angle triangle. Okay, so the E net will be square root 2 of one of the E electric field. Okay, so will be square root 2, okay, times 1 over 4 pi 8.85 times 10 to the negative 12. Q is 2.5 times 10 to the negative 6, 0.6, 0.6 square plus 0.6 square. Okay. Okay, pressing your calculator, you get 6.24 times 10 to the 4 newtons per coulomb. Okay, the direction is 45 degrees below the horizontal to the left. Okay, so this is the answer for part A. Okay, then in part B, we want to find the magnitude and direction of the net force when we place an electron. We release the electron at point P. Okay, so F net equals to Q times E net. Okay, and so the magnitude of the force okay, so note that so we have a negative charge, and then the electric field is pointing in this way, E net. Okay, our F net will be pointing in the opposite direction. okay, because it's a negative charge. Okay, so the magnitude of the force is going to be 1.6 times 10 to the negative 19 times 6.24 times 10 to the 4, get 1.0 times 10 to the negative 14 newtons. Okay. Okay, then the direction of the net force, direction of F net is equal to 45 degrees above the horizontal to the right. Okay. Right, so that's all for this question.